Welcome to Building Scalable Multi-Tier Systems with DataSnap and C++ Builder XC3 CodeRage 7 session. My name is Pawel Glowacki. I'm working for Embarcadero as EMEA Technical Lead for Delphi and RAD Studio. And today I'm going to demonstrate building DataSnap scalable systems with C++ Builder XC3. And I'm going to use the latest available beta build for the upcoming 64-bit support in C++ Builder. So this is going to be all about demos, so I don't have so many more slides. This is actually the last one before I will switch to demonstration. So with DataSnap, you can create multi-tier systems, so basically applications that communicate over the network. So in this way, you can create applications, server applications that runs on Windows and implement them in C++ or in Delphi, and they can accept incoming connections using TCP/IP or HTTP protocol from clients implemented in different languages, including C++, Delphi, JavaScript, Java, C#, Objective-C, and other, running on all kinds of different platforms, including smartphones, desktop devices, and different operating systems like Windows, Mac OS X, iOS, Android, and other. So in this demonstration, I'm going to start with a DataSnap Hello World example. I'm going to build a simple DataSnap server as a VCL Forms application, listening on a TCP/IP port 211, and I'm going to also build for it a client implemented as a FireMonkey HD application, so potentially can be compiled also to Mac. And I'm going to just implement a straightforward functionality of reversing the string. So the client will be sending the string over the network to the server. The server will be performing the reverse string operation and sending this back. Then I'm going to demonstrate the process of changing the server implementation and also updating the implementation of the client. And then I'm going to use wizard, client module wizard, to do the previous steps in much more easy way. Then I'm going to move into the authentication and authorization. So I'm going to add authentication and authorization to my existing application. In the next demo, I'm going to build different types of database applications. So I'm going to create a multi-tier database applications. Okay, let's switch to another virtual machine that I'm running here in this presentation. So I need to actually go out and switch to my Windows 7 box with C++ Builder XC3 Beta 10 installed. And let's start with a simple DataSnap server, and then I'm going to add to it a DataSnap client. So I'm running C++. So to start, I need to actually go to a special wizard. In a DataSnap server category, I have different wizards. So this first wizard and the last wizard would create for me DataSnap servers that will be implemented as web applications. But I'm going to use a DataSnap server wizard that will create a standalone application that can actually be implemented as either VCL Forms or console application or even service application. So this last one is quite useful in practical implementation, as it can start with operating system starting, so you don't have to do any manual intervention to start the server. But for demo purposes, I'm going to keep it simple. So let's go for a VCL Forms application, and then on the next screen I can select the features of the server. So first of all, I can specify which protocol I want to use. So I want to use TCP/IP, but at the same time I could have used also HTTP as well. Then I can go for authentication and authorization. So basically I'm going just for authentication, So this will basically add to my server the DS Authentication Manager component that I will use later in the demo. Also, I want to generate some sample methods, so this is the functionality that clients will be able to call. I can also add filters, so basically this means that filters is in DataSnap lets you perform operation on the actual raw stream of bytes that are sent over the network from the client to the server. So out of the box we get encryption filter and compression filter, but you can also implement your own. There is also option to add JavaScript files, so this is useful for HTTP servers when you can actually generate some sample JavaScript clients. So this is a situation when you have a server implemented as C++ or Delphi application, but the client is a JavaScript code running within the HTML page inside of the web browser. The last option is to capability to generate mobile connectors, which means I can generate a client-side proxy code in other languages. So, for example, I can generate code in Objective-C for creating clients for iOS, or implement or generate code in Java for Android clients, or PHP code for server-side web application, and so on. So for this demo, I just stick with this selection. Just want to have a TCP/IP. Just want to have an authentication without authorization at this stage, and just server methods and sample methods. Okay, so let's go next. I'm going to see if the port 211 is open or if there is any other application not listening on this port. So it's open, great. And then on the last page of the wizard, I can decide what would be the base class of my server methods implementation. So in DataSnap, the functionality that is exposed to clients is implemented on the class that is called a server methods class. So this is an ordinary C++ or Delphi class, and every public method or published method on this class is automatically made available for clients to be called. So this is very powerful, and also here we can decide what would be the base class of this implementation. So depending what you want to achieve, you can choose for simple stuff, we can go for T component. If we want to use some non-visual components like database connections or SQL queries in the server implementation, we may want to go for T-data module, which is a non-visual, is a great for placing non-visual components. And in the last option is TDS server module. So I'm going to use it in the last demo. This is great for application when you want to have a multi-tier database application with provider components on the server side. So you can have easy create a multi-tier database application with possibility to update server-side data. Okay, I'm going to go for a T component because it's going to be just a hello world demo. So click on finish, and the wizard will generate a bunch of different files for me. The first thing is to actually save everything in some good location. So I'm going to create a new folder, my hello world, and inside of this my hello world I'm going to create a subfolder called server for all the server files for the server project. So I'm going to keep all the defaults. So main form unit 1, there is server container unit, there is a server methods unit, and also the project itself. So it will be my hello world server. It's a nice project. So at this stage I have a fully functional server, DataSnap Server. It's by default it is created, the wizard created it as a Win32 application. In fact, now I can actually compile it also with a new 64-bit compiler, so I can just add to the target platforms a 64-bit platform and make it default automatically. So basically From the perspective of the this demonstration, it doesn't really matter if it's 32-bit or 64-bit, but let's make it more interesting, and the 64-bit is the new compiler that is just being introduced to C++ Builder, so let's use this one. The other elements that are part of my project is my Hello World server. So this is the main project file. So we can see there is this form class, and so because this is a VCL forms application, so that's why I have a VCL form as a main form of my application, but it does not have any meaning, so we don't have to spend time discussing this one. More important are these other two units. So the server methods unit is the unit where you have your server functionality implemented. So that's the beauty of a DataSnap architecture, that basically you just need to implement public methods on the server methods class, and they will be automatically available to the client. So the wizard has generated for us just two methods. So one echo string method that just takes the string and just returns the same string, so it's not very interesting. But the second method is slightly more interesting. It's reverse string. It takes a string and returns the same string but reversed. So this is the implementation, and this is the header file for this class. So we can actually see that these are the two public methods implemented on a server methods class. So that's the functionality we want to expose to the client. Other components, other non-visual components are there inside of the server container unit. So these are the components that really transforms this C++ Builder VCL forms application into a DataSnap server. So first of all, we have a DS server component, and we need only one component, DS server per application. And this is basically the component that has methods like start, stop, has a property auto start by default set to true. So when the server starts, it immediately starts to listening to incoming requests. So these requests can be coming from using different protocols on different ports. So here we have selected in the wizard to add TCP connectivity. So we have a DS TCP server transport component. So this component is connected to the server through the server property. Also, it has the port 211. So this component basically internally is implemented as a indie multi-threaded server. So any DataSnap application is inherently multi-threaded, and you don't have to do anything to make it multi-threaded. In fact, application in DataSnap application can listen simultaneously on multiple ports and on multiple protocols. So we have just selected TCP/IP, but we can, for example, make it to listen on multiple ports. So, for example, I can add another DS TCP server transport component to the form, and basically, for example, change the port to be 212. And yeah, I need to also hook the server property to the server. And also, because we have an authentication manager component, it has to be also connected to the transport through the authentication manager property. So also on these transport components, I can define filters. For example, you can specify some of the built-in filters. So these first two are related to encryption. You typically use them both together. The last one, zlib compression, actually compress the traffic. So I don't want any filters in this example, but I could have add one. So then the functionality that the server offers is represented by the DS server class. So this is a component that acts as a bridge between the DS server component, the heart of the DataSnap server. So it's connected to this component through a server property. You can see it here in the designer, in the object inspector. But at the same time, it has an event called onGet class that was implemented by the wizard. And this event onGet class basically tells the DataSnap server what is the type of this server methods class implementation. It's important to realize that we as programmers, we are not responsible in code for creating and destroying instances of this server methods one class. We basically tell the server, okay, this is the type, and the second thing that we need to do is to specify the lifecycle option of this class. So by default is session, which means that for every connected client, the moment it connects to the server, there will be created one instance of this class inside of the server. So the client will call methods on this instance. So it resembles the same model as in JEE, Java Enterprise Edition architecture. There are enterprise Java beans and there are stateful Java beans. So they remember the state across the different requests. So that's quite a similar model. The other option is invocation, which means that server methods instances are created and destroyed on the fly, so they are only existing for the duration of the method call. So this is similar to stateless EJBs, and potentially this is the most scalable option. So you can have hundreds and thousands of clients connected, and they will make calls, so they will not have to have their own components inside of the server. Maybe even more performant will be the server option, where you have only one server method class instance, and all clients are calling the methods on the same instance. So this is potentially also very scalable option, because there is always only one instance of a given server methods class in the server, but it also requires that the implementation of such a server methods class is thread safe, because potentially there could be calls from multiple threads to the same instance. So I'm going to keep it as a session, so this is the default value, and let's keep it like this. So in order to develop a client, you need to have the server needs to be running. So the first thing is to actually run the server, and it has to be running, and I'm going now to add to the project group a client project. So this is the beauty of a DataSnap architecture, that is very dynamic. So we don't have any external information about the functionality that the server provides. So in other similar technologies like DCOM, we have a type library. In other technologies, we have in Corba we have interface definition language files. In SOAP web services we have WSDL files. Here the server is self-describing, so that when we build the client, it can actually at runtime it can figure out from the running server what are the capabilities that the server offers. Okay, I have started the server, so I see there is a Windows security alert that's saying that my hello world server is now listening on a certain port, okay, for incoming connections from the external world. So potentially this is a threat to the security to my system, but I want to allow access, otherwise it will be difficult to continue with this presentation. There is also a warning about the duplicate resource here at the bottom in messages, but you can easily disregard it. It's not really important for this presentation. And yeah, our server is running. We can now build a client to it. So So to the project group, we right click on a project group, add new project, and I'm going to select the FireMonkey desktop application. So in this way, this is actually, I could have had other applications like MDI application or VCL Forms application, but in this case I would be limited just to Windows. And if I select FireMonkey, I can create from the same source code, I can compile my client to be running either on Windows or Mac. So this is really very powerful, or in a quite near future on other platforms like, for example, iOS. So I'm going to go for a FireMonkey desktop application, click on OK, and then I have a choice whether I want to have a 3D user interface or just traditional two-dimensional one. So let's keep it simple, like going for HD FireMonkey application, and I need to save it in the same directory as this application. So that was my hello world. I'm going to add a new folder, client, and inside of the client I'm going to save everything as default names, except maybe for the project will be my hello world client, and the project group I'm going to save a little bit higher, my hello world. Okay, so that's my my client. Inside of my client I can actually now the first step to actually build a client is to add a T-SQL connection component. So this might seem strange because, okay, this is a typical component for creating database applications that connect to a remote database. And looking into the Data Explorer, you can see that there are different databases supported, like Oracle, like SQL Server, like DB2, like Sybase, and one of the databases or one of the drivers is DataSnap. So basically this means that back in Delphi 2007 and C++ Builder 2007, the DB Express framework for database application has been redesigned in pure Delphi code in a very elegant architecture. And in the next release, in Delphi 2009 or C++ Builder 2009, the DataSnap architecture has been redesigned as an extension of this new DBX4 architecture. So from the perspective of the client application, the remote server looks very much like a database, and the functionality that it offers looks very much like stored procedures. So that's the reason that to develop a client, I need to add to it a T-SQL connection component. And this SQL connection component, I need to set the driver to be DataSnap. In this way, basically, there is a special DataSnap driver that implements a special protocol that allows, instead of talking to the database, we are talking to the server. Here we can specify the communication protocol, could be TCP/IP, HTTP, HTTPS. We can specify the address of the host, so local host, or can be, for example, the actual IP address, and also the port by default 211. It's a good idea to actually set login prompt to false. We don't want to have this login prompt. And we can see if we can actually connect to the server by trying to set the connected property to true. Yes, we can connect. In fact, we can also check if we can connect on port 212, and yes, we can. So we have now a multi-threaded server. Okay, so that's a starting point. And now, in order to call server-side functionality, I need to generate some client-side classes, client-side proxy. I right-click on the SQL connection component and select the third option, Generate DataSnap Classes. Click on Generate DataSnap Classes, and I see there is a DataSnap proxy generator generated for me, C++ source code with different methods, the class with different methods, and actually this is the class is tServer methods 1 client, and it has the same methods echo string and server string that the server side that the server offers. So basically, the first thing is to actually save this guy. So I'm going to call it proxy because it is effectively a proxy to the server side functionality. I can actually have a look here, and my proxy has also a proxy H. So this is just a class that is derived from a T object, and it has the same functionality as the server provides. So in order to call remote methods, I just need to instantiate this class, and there is a constructor will take as parameter a dbx connection. So this is actually a property of my SQL connection component that is on the form that contains all the information about to which server we want to connect. And from this moment, I just need to call these methods locally, and they will be actually sent to the server, and the result will be sent back. Okay, so let's save it, and in my unit 3, which is my client, I'm going to just add to it a T button component, okay, like this, and also a T edit component. So I'm going to inside of this edit, so basically I'm going to take the contents of the edit, send it to the reverse string method, and display the reverse string inside of this same edit. So I'm going to put something like C++ builder exe3 64-bit rocks. So that's my string to be reversed. So now I'm going to double click on a button, and here I need to actually, in order to use classes from this from my proxy unit, this class, I need to add this proxy header file as an include to my form files. I'm going to copy this, but here in my unit 3, to make it easier, I can actually just go and say use unit proxy cpp and click on OK. So this is a easy way to quickly add this one include line, and now I can just define this proxy class. So I need to actually define this as a reference. So the variable will be called client, and I need to instantiate this class, and here in the constructor I need to actually pass the SQL connection property called dbx connection, and that's all that I need to do. But actually, before I can do it, I need to make sure that the connection to the server is open. So I need to also write this one line of code, SQL connection open. So here, from this moment, I can call these client methods, and they will basically, effectively, I will be calling a server method. So let's actually add an edit text and client reverse string, and here we can actually add an edit one.text. And when we are done with a client, we need to make sure we release it, so we can call delete on the client. So now if I run this application, I should see that there are some errors. What he does not like, okay, I forgot one character here, so now I can run it again, and I should have my running client with no problem. So button, and we have a reverse string in action. So in this way, I was able to actually build the server and the client very easily. So sometimes you may ask, okay, what do I do if I want to add or change the functionality of the server? How do I update the client? So that's a very good and valid question. I can actually go ahead and stop this guy, yeah, I'm going to add to it to the server a new functionality. So switching to the server project, going into the server methods unit, and adding there a new functionality. For example, let's add it to it system dot. We are going to return again a Unicode string, and this is going to be just a hello world method that will take no parameters and just returns the string. So we will implement it that it will return a hello world plus plus the current time on the server. So here in the server methods unit, we can actually add this method here very easily. So, but I need to prepend it with a t server methods 1 and hello world. So okay, and instead of a semicolon, we need to provide implementation. So return some hello world add, and we can add a current date time to string. Oh, no, it's not typing a little bit too fast for this environment. So it actually hello world, and that's not exactly what I want. I want date to string, and here I can provide now, so that will return a current time at the server. So now I can rerun the application, and it will inside of the client I should be able to so server needs to be recompiled and rerun. I can go to the client, and inside of my unit 3 on the SQL connection, I just click on generate DataSnap classes again, and I can see that my hello world call has been added automatically. So now I can just start using this new functionality. So for example, I can maybe add to this form a label, label, and this label, yeah, we can make it longer because it's going to be longer string, and inside of this call we can now call something else like label1.text equals client, and then hello world. Okay, so now we can just run it to verify that it's actually doing what we want. Click on a button, and that is working. So that's a process to actually changing the server, changing the server and adding some more functionality to it. This can be also simplified with a wizard. So I'm going to actually add to this project group very quickly exactly the same client application, but this time I'm actually going to use a wizard to do this work that I have done much faster. So I'm going to save it. So here my hello world is somewhere here. I'm going to add a new folder for client 2, and inside of the client 2 I'm going to save everything as it is without any changes. But this time, instead of adding a SQL connection and generating proxies manually, I can just go for a new other DataSnap, and here we have a DataSnap client module, and that will actually make it this process much faster. Click on OK. It will ask me for the server, local server. I can go for a DataSnap standalone server, TCP/IP. Port is actually 211. Test connection, so that's important. If you cannot connect, you won't be able to proceed. Click on finish, and basically I need to save some of the files that were added to the project. So there are 2 files added: the client classes unit, which is effectively the proxy file that we have been generating manually with all the latest information, and there is also a client module unit. So this is a data module that was generated for us with a SQL connection component already pre-configured to point for the DataSnap driver, login prompt to false, all the appropriate connection. And also inside of the implementation you can see these calls that we've been writing manually, opening the connection, actually instantiating the fServer methods one client, and then this functionality is actually made available as a property. So basically you don't have to do anything. You just need, if you want to access the server-side functionality, you can just access this property of the client module, and you should be okay. So in my code, in the unit for code, I can just add a button, button. I can add a label as well, label, and add it like this, so we can make it actually longer, and save it. And here I only need to use this client module, so use unit client module unit, so that was added to the form, and now I can just label one dot text equals client module 1, and we have this server. Actually, probably I need to split it into the two calls, so to make it a little bit more readable, I'm going to Control C, unit 4, I'm going to put it like this. So this will be my client, but now I don't have to do anything. I can just take this client from my client module server methods client, and now I can just call its method without worrying about anything else, just like this. So client, and I can call, for example, the hello world method. So now this is actually a wizard that simplifies a little bit of those steps that we have been doing manually, and now it's much more simpler. We can also add authentication and authorization to our server. So let's actually stop the server and see how we can do it. So I'm going to actually go ahead and select close some of those client-side classes, so we have more space. Actually, I'm going to close almost everything, so it's easier for me to find out what's here in the editor. So now I'm not really interested anymore that this project has been added. I think, okay, that's my client. I have not saved it, but I'm going to actually modify the server and add a functionality to it to provide authentication and authorization. So here in the My Hello World server, I already added in the wizard the authentication manager component. So this authentication manager component has these two events, on user authenticate and on user authorize. So this I have only selected for authentication, but because that's what I need to use. So basically in this method, when the user first time connects or client connects to the server, it needs to provide username, password, and based on this information like username and password, and also other things like protocol, you can make a decision whether the user is okay to connect to this server. So, for example, we can make a rule that if the user is actually empty, so there is no username provided, we say, okay, valid is false. Okay, so otherwise we say, okay, so this user is valid, which means that he will be allowed to access our server implementation. The second thing we need to do is to add the user to the roles. So there is this parameter roles, user roles. So for example, we may decide that certain functionality of the server, certain server methods can be only accessible by a certain clients. So for example, if the username is admin, we will add it to the admin's role, and we will make sure that only admins can call the reverse string row. So I'm going to write this code again. So here in the if the user is actually used is admin, then we are going in the body of this if statement. I'm going to say, okay, user roles, and I'm going to add to this user roles. I'm going to add this user to the current user to admins roles. Okay, I'm defining the admins roles. Admins role. Okay, so at this moment I have certain functionality in place, but then authentication manager also has this property called roles. I can use it to specify, okay, what are the methods and which roles are actually authorized and which are denied. So I can specify that this rule actually applies to my server methods one class, and the method is called reverse string, and the authorized roles are admins. Okay, so actually I need to use for it this editor, so admins. Okay, so now I can actually go ahead and run this application, but this time I'm going to use a Data Explorer to check the functionality of the server. So Data Explorer has been redesigned in XE3 and is quite much more functional. You can see that I can without building a client, I can test the functionality of the server. So I'm going to actually go for a new connection, and this connection will be my hello world connection, and here I can specify the protocol hostname, but also I can specify the username and password. So let's actually not specify any user, and see if I can connect. So this should not work. So test connection, and I get this failed, remote error, authentication manager rejected user credentials. So that's what I have been expecting. So user is empty, so it's not authorized to connect to the server. So that's great. Okay, let's actually go further. The username, let's be C++ builder developer. Okay, test connection succeeded. Okay, so now I can actually open this node, and inside of the server methods I see plenty of different methods. So there are lots of methods that are built in every server. There are two built-in server methods classes, DS metadata and DS admin, and also there is our DS server method. So here I can have my reverse string. So now I can actually try to call it, and it should not work because I'm not admin. So I'm going to say something hello or whatever I want, click on execute, and I get this remote error. C++ builder developer is not authorized to perform the requested action. So that's exactly what I want. So this is exactly the same error that the client would receive when trying to call this method. So in order to be able to call this method, I need to actually specify that this is going to be not just username whatever, but specifically admin. I can actually click on OK, and here if I now go for a reverse string, I can now click on OK. Actually, still I need to open this one more time. So hello world, refresh, and server methods, and now I go to the reverse string view, and whatever I put here, click on OK. I should see that I'm successfully can retrieve information. So that's very powerful stuff, and as the last demo, let's see what it takes to actually create multi-tier application. So I'm going to actually go for a new type of the application that I have relatively recently discovered that is possible. So you can actually use DS provider connection component, which is quite powerful, and I have this demonstrated on my DataSnap Labs, or actually Delphi Labs webpage. But you can also use a SQL Accelerator component. So that's actually SQL Accelerator functionality. Let's have a look how it works. So File, New, and Other, and I'm going to go for DataSnap Server with this VCL Forms application protocol. I can actually remove any methods. I don't need methods. I don't even need server methods. No, server methods class I need, but I don't need to have any sample methods. Test port. Okay, it's busy, so it will take a moment until this application can stop. So that was my fault. So now if I click on stop, it will be not responding for a while. Or actually it stopped very nicely. And click on next. And now I need to make sure, actually I can probably go for T-data module, just data module, so I can put a SQL connection component on it. So using this SQL Accelerator functionality, we can from the client directly access the server-side SQL connection component. That's a very intriguing possibility, because I'm going to add to new accelerator, and here I'm going to add just save it as unit 1 and all the default names, and the project will be my accelerator server. Okay, so basically I can specify in my I want to access a database, in this case employee database on my server. I just need to put on the server methods unit the connection to the database. So in this case I just going to connect to this employee database. So just drop a connection on the form. So this is the connection I want to access from the client. So this is very intriguing possibility. Click on save, run this application, and now inside of the Data Explorer, to keep things simple, I'm going to actually define a new connection. So super connection, click on OK, and here there is this SQL Accelerator thing. I can open it and specify DS admin get connection, and this is where I need to actually enter the actual name of the connection as it is in the Data Explorer, in this case employee. Okay, click on OK. So now I can add to this, just make sure that actually this server is already running, so I need to just add the client. So I'm going to add a new project, click C++ FireMonkey desktop application, HD application, save it, and here in my super accelerator, where it was, my super accelerator, oh let's, I'm not sure where it was, but could be this one as well. I can just call it whatever I want, and just project will be accelerator client. Click on save. Project group does not matter what it's called. And now on the client, I can just, instead of adding a SQL connection, I can just take this super connection and drag it to the form. So this is powerful, because you see I have a server connection employee, and this is like if I have this server-side connection on my directly on my client. So now I can just build a database application in a normal way. So for example, I can use live bindings wizard, link a grid with a data source, select to add a new grid, select a bind source DBX component. I can see all the tables that the server-side SQL connection sees. For example, I don't know, customer, click on next, add a new dataset navigator, and here I have a navigator, make it to the top, and have a grid component, make it to the client, and yeah, in this way I can create a multi-tier database application using SQL Accelerator technology. Okay, so that was it for this session. I'm going to switch to the just last slide in this presentation. So in this session, I have demonstrated C++ Builder XE3 for creating multi-tier scalable applications using DataSnap technology. I have demonstrating building just a simple TCP/IP based client and server systems, modifying server and client implementations, using client data module wizards, adding database, adding authentication and security to existing database, existing application, and also I have demonstrated how you can use a SQL Accelerator technology for accessing the server-side SQL connection components from the client. So thank you very much.
So does using TDS server.broadcast object, will that help me send large C++ objects to the client without marshalling and unmarshalling?
Actually, you need to marshal anything that you send from the client to the server and back. So basically, the nice feature is that you can have this marshalling process happening automatically. So that was something that was actually the C++ functionality, I believe, in XC was lagging behind Delphi functionality in the support for passing arbitrary T-object descendants from DataSnap methods, and also this is also applicable to broadcasting. Now, since XE2, there is whatever Delphi servers can do, C++ can do as well. So you can also return T-object descendants, and also you can broadcast these objects. So the nice feature is that they will be automatically converted to JSON and back. So basically converted to the underlying transport protocol. So the connectivity, the TCP/IP connectivity between clients and servers in DataSnap are used based on a custom protocol that is based on JSON. So whatever is sent between the client and server is typically encoded as JSON. So the answer would be probably you can use this to broadcast, but it will be automatically marshaled. So you cannot avoid marshalling of arbitrary data structures.
Very good, but you don't have to think about it. It happens automatically. That's very cool. Do you recommend one DataSnap server that does everything, or do you split up and run a number of DataSnap servers that have different functionality but all run on the same server?
I think this is very much important related to the architecture that you want to implement. So in DataSnap, this is a multi-tier distributed architecture. You have to take into account how you deploy your server. So this also influences your implementation decisions within your application logic. So looking at the server implementation internally, basically there is no good reason to implement too many server methods inside of the same server. So probably when you want to have different lifecycle options for different server methods, that's the reason to have more than one server methods class with different lifecycle options. So it all depends on a functionality that you want to implement, and also typically you would like to have for example, when you want to achieve scalability, you may want to have exactly the same server implementation, but running on multiple different computers, or in case of the cloud, like Amazon EC2 cloud, on different on the same load balancer, so they can be, the instances of your DataSnap servers can be automatically started and stopped depending on the incoming traffic from clients. So it's a matter of an architecture decision. There is no good answer to this question.
All right. Is there a command to tell the server that the session should be destroyed for now? For instance, when the program ends and will not return perhaps for the rest of the day?
Yes, that's actually the feature that was introduced in DataSnap XE2. So in a previous version, so this is a connection control. So basically, at any time, the server can programmatically terminate any of the clients that are connected, any of the sessions that are running inside of the server. So there is also a timeout that you can use. If there is an inactivity from the server, it will be terminated. So there is plenty of options here. So yes, there are ways to disconnect the client from the server programmatically.
When deploying the server to another computer and perhaps network, what is needed to configure to make the DataSnap server know about the database, and what is needed to configure in the client to understand that the DataSnap server is not on the local host?
Okay, so basically that's a very good question, because in a typical demos when we use wizards, the information about the, maybe first I will reply to the second part of the question, because I think it's more relevant, that when you define a client, when you build a client with a wizard, and in the wizard you specify the username and password, and you also, if you select on the client wizard that you want to have it on a remote machine, then you have an option to actually specify the host name, the port, the username, and the password. And this data basically ends up in the params property of a SQL connection component. So this is you can actually open this T-SQL connection component, open properties of the T-SQL connection component, and in the params you will see there are entries for a DS authentication user, DS authentication password. So this is something you can programmatically change in your application. So if you want to implement a client that can actually connect to different servers, when you don't want to hard code it inside of the client implementation, you need to programmatically change these parameters of the SQL connection. The first part of the question was about the server side. So in many situations, you want the server to access the database. So it's also not a good idea to hard code this information in the server. So you may want to actually read the connection string from either a configuration file or maybe some kind of a bootstrap service that you want to implement. So there are plenty of flexibility here.
All right, and you also linked to the Rat in Action Delphi Labs, which is a great link, great resource, and you also link to an article here for the multi-tier demo for the DS provider connection. Is documented on ADN in an article 41189, and that's listed in the Q&A log here as well.
Yeah, so basically there is more information available in my Rad in Action Delphi Lab series. You can Google for it. It's the source code is based on Delphi and specifically on Delphi XE. So the source code will probably not compile as is in XE3, but the ideas are the same. There are little changes that needs to be made to the source code. And I have just right now on my blog, you can go to blogs.embarcadero.com. The first post is the blog post with references with a download location for the slides and for the demos that I have demonstrated in this session.
All right, sounds good. And you blogged that as well. It's on your blog from today, 12/12/12. Sounds good. We have professional but are looking to upgrade. Is there a way to try DataSnap without a full upgrade of XE3?
No, I believe there is not, because the DataSnap is a functionality of the enterprise edition of Delphi or C++ Builder, and it's not available in professional. So you need to upgrade to enterprise, and actually it's a very good offer right now to buy enterprise and get all the database tools that comes with the ultimate edition. But if you want to give it a try, you may want to download just a trial, and trial version of RAD Studio contains this functionality. So you may have like 30 days to give it a try and to see if it works for you. And yeah, it's very powerful technology, and it's very RAD oriented. So yeah, I do recommend going for enterprise and giving DataSnap a try in real deployments.
And if you download the trial, make sure that you don't install it on the same machine that you have a lower SKU or even the same version of the product. That if you have XE3 Professional or XE3 something, you do need to install that trial on a different machine or in a different VM, otherwise it will collide. So
yeah, that's a very good point, because the trial version is not the same installation as a retail version, so it is not as simple entering a serial code to unlock certain functionality. It's a different install, so yes, definitely you want to install trial on a different machine.
Yeah. Are the roles only identified by a string, or could different integers be used?
Yeah, so the question was about roles in authentication and authorization framework in DataSnap. So a role itself is a string. So string as such can contain numbers as well. So at the end you use a string, but there's nothing that stops you to add numbers into this string.
Where can we find DataSnap examples and DataSnap white papers in C++?
Actually, that's a very good question. To be honest, there is not so much content available for C++ DataSnap. So this is on my to-do list to provide some of the more demos on C++. So basically what I'm looking at right now is to update my Delphi Labs series with demos for XE2 and XE3, but also for C++ XE3 to make it more complete. But other than this, I'm not so sure. I'm not aware of really great C++ DataSnap specific resources.
All right, so with that, there are no more questions. So thank you very much, Pawel.